fiber is created equal, but one of them, inulin, may have a secret superpower. It might not just help your gut microbiome, it shields your liver from the potential damaging effects of fructose. And while I am usually not a fan of focusing on singular nutrients or research papers, this one deserves the exception 100%. The study in question is an animal study. It was published about 2 months ago in September 2025. It investigated the impact of high fructose corn syrup rich diet in the combination with inulin on the liver and the gut microbiome of mice. Why did they choose fructose in particular? The excessive consumption of fructose, which is primarily due to the inclusion of high fructose corn syrup in all kinds of processed foods, has been linked time and time again to the surge of many metabolic diseases, not only obesity, but also the development of the so-called non-alcoholic fatty liver disease. Fructose is not metabolized the same way as glucose. It bypasses the insulin-mediated regulation of sugar, and it is broken down primarily in the liver. Over there, it boosts, unfortunately, the so-called de novo lipogenesis, which is the conversion of carbohydrates to fats. Over time, fat accumulates, which results in more severe inflammation and could even lead to fibrosis. With the increased incidence of this condition, it calls for the development also of non-pharmacological strategies to improve the condition without the side effects of some of the medicine that one would usually have to take. Going back to the research paper, the study participants were 30 male mice, and they were divided into different groups depending on the diet that they were fed over the course of 30 weeks. The first group was consuming a standard control chow diet. The second one was fed an inulin diet. The third one was fed the control plus high fructose corn syrup enriched water. The fourth one was fed high fructose corn syrup enriched water also with inulin. And the last group was a bit more special, since in the first 16 weeks of the study they were fed the control plus fructose diet, and in the remaining 14 weeks they were given the inulin plus fructose diet. And the idea here is to see if some of the negative influences of fructose on the liver could be reversed when inulin is administered to these mice. The findings of this experiment were strikingly positive in every aspect that the researchers investigated. Starting off with the fat mass percentage of total body mass of all of the mice, the ones that were fed the inulin fructose diet had a lower fat mass percentage compared to the control plus fructose diet. Next, looking at the liver tissue of all of the mice, there was evidently less liver fat accumulation in the group that consumed the inulin plus fructose diet compared to the control fructose diet. But probably the most important and most groundbreaking finding of the paper was the reverse damage in the combination group. Due to them switching to an inulin fructose diet, they had now suffered less fat accumulation than the group that was consuming the control fructose diet the entire duration of the study. All of this indicated that the administration of inulin led in some way to a rewiring of the fat metabolism in these rats. According to the researchers, the administration of inulin had significantly boosted the fat metabolism in the liver of these mice through a variety of different mechanisms, starting off with the improvement in fatty acid oxidation, so fatty acid breakdown, a decline in the de novo lipogenesis that I talked about earlier. This means decreased rates of formation of new fat in the liver, and finally an increase in glutathione production, which is a very powerful antioxidant. This could help mediate an increase in inflammation due to the excessive consumption of fructose. Inulin basically equipped the liver with a combination of tools so that it can defend itself against the damaging effects of fructose. When looking at the gut of these mice, it was observed that any of the groups that were fed inulin, whether it was the inulin plus fructose or the combination group, all of them had significantly lower levels of fructose present in their colon. And this is of crucial importance for the gut health of these mice. Fructose and glucose, all simple sugars, in excessive amounts in the colon lead over time to gut dysbiosis. So how did insulin limit the amounts of fructose that reached the large intestine? The so-called phenomenon fructose spillover is detrimental to both the liver and also our gut. Essentially, it reflects the amounts of fructose that could not be metabolized in the small intestine and went over to the colon or to the liver. Inulin had drastically decreased the amounts of fructose that would normally spill over by influencing the composition of the gut bacteria that is in our small intestine, not in our large intestine. This finding in itself is also groundbreaking, since it was thought for a very long time that prebiotics can only exert their function in our large intestine. Scientists then attributed these effects to a specific strain found in the small intestine and even validated their findings further by giving these mice antibiotics. And in that case, the positive influences of inulin were practically neutralized. I don't know if any of the papers mentioned this, but for me it seems a bit logical that inulin would boost the metabolism of fructose in the small intestine, since inulin itself is a polymer that contains glucose and very long chains of fructose. Therefore, in order to break down inulin, the bacteria would have to possess enzymes that are equipped to metabolize fructose. In the light of these amazing findings, I believe that now the question arises whether you should be supplementing inulin and where can you find inulin naturally occurring in food products. Inulin is not really a new topic of research. It is a soluble and fermentable fiber that has been investigated for some time now. It is present in good concentrations in artichokes, chicory roots, asparagus, garlic, onions, not a very long list of foods. Because it is a fermentable fiber, it has been thoroughly researched for its influence on our gut microbiome composition. Inulin has been attributed the so-called bifidogenic effect, which reflects its ability to increase the population of some strains that are beneficial for us, specifically the bifidobacterium strains. Therefore, it can also decrease the so-called F to B ratio, which has been discussed in a lot of scientific studies for a potential link to the development of metabolic diseases such as type 2 diabetes and obesity. As a consequence of this fermentation, there is also an increased production of the short-chain fatty acids, which have numerous positive effects on our health, and they play a role in gut barrier function, our immune system, and also our energy metabolism. On top of all of that, short-chain fatty acids also appear to enhance insulin sensitivity and boost GLP-1 secretion, which plays a significant role not only in appetite control, but also in the release of insulin. Because of all of these positive findings, inulin has the potential to play a significant role in future dietary fiber interventions which target specific bacterial strains in precise locations at the gut. This might be one step further towards developing highly personalized protocols for each individual, depending not only on their metabolic condition, but also their own gut microbial composition. But until we get to that point, supplementing inulin might not be the best choice for every single person. While inulin from the diet is generally well-tolerated, highly concentrated inulin in the form of a supplement can cause for a lot of people some severe gastrointestinal symptoms such as bloating, heartburn, acid reflux, diarrhea, and these symptoms might be very exacerbated in individuals that already suffer from some gut issues, specifically inflammatory bowel disease. Because of this, nobody can recommend supplementation of inulin to the general population. However, including more of those specific foods in your diet is one way that you could test what your own tolerance for inulin is. And in the end, in the case that the findings of this trial are validated in humans, prevention is always much better than intervention, and it would be better if you would not damage your liver in the first place, so that you would have to neutralize it with inulin. Abstaining from the excessive consumption of fructose, primarily through high fructose corn syrup, is the best way to go about this. Thank you so much for being here with me today. I hope that you enjoyed the contents of the video. Let me know down in the comments below if you would like me to discuss something of your interest next time. Do not forget to like and subscribe if you enjoyed, and also check out my socials in the description, along with my website where I have some additional resources and my own nutrition counseling services. Thank you again for watching, and I will see you in the next one.